Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about hydrogen energy storage. So let's dive right into it. Now first you have to understand why we are talking about hydrogen. Well, reality is in terms of normal everyday day-to-day use EVs, battery system has won. It's done, game over. As in, like, I have heard about basically hydrogen cars as early as 2008 that was made and mass produced either by BMW and Honda, and they even Toyota. They reached market but they never took off. As in, at this point in time, they are countable, like barely 5 to 10,000 pieces compared to lakhs and lakhs, like 100,000 units of electric vehicles. And electric vehicles have reached what we call momentum, meaning they're gonna sell on their own. At this point in time, because of the rising fuel price, people are buying EVs. So EV have won flat out in that department. However, in terms of industrial use, in terms of semi-truck use, they cannot compete tangibly. So for basically battery to become viable for this sort of puppy, it requires around like for semi-trucks it needs like 2 to 3 times energy density, which cannot be had because lithium has this lithium ion system has this kind of energy density. We have almost reached it because like you will never thermodynamic efficiency will not allow you to physically touch it. So we have reached a maximum point. And you may be like, what about other chemistry? It takes decades for some chemistry to be selected, chosen, fine-tuned, refined, then mass produced, then market feedback, and then to become normal thing like lithium ion. So it's not something that you're gonna see tomorrow. So at this point in time, battery technology has reached a maturity, meaning the only thing we are right now working on is making it cheaper or far easier mass producible. So at this point in time, the fact is electric semi-trucks do not scale well. Electric trucks do not scale well because if you think of it this way, if you're talking about a normal civilian everyday basic use car, it's best for you to have basically small battery system, meaning if your daily travel is barely exceeding 60 kilometers, you're gonna buy a battery system that is around good for 100 kilometer range, simply because it will be lighter, meaning per kilometer energy expenditure would be less. Now compare that to, let's say, something that has like 500 kilometer range, you would be expending far higher energy, like almost 3 to 4 times higher energy, just because you have carrying that extra range. So there is a point of diminishing it. It's like rocket. How the bigger you make the rocket, the less likely it becomes to be successful, simply because it's just carrying its own fuel rather than any payload. So same happens with electric cars. So around 1,000 kilometers in terms of range, it's flat out not feasible. It can be done, but it won't be feasible. It will be like, a car that is like very, very, very heavy. It may even become road illegal, that heavy it would be. So there is a limit. Battery electric vehicles do not scale up well. They are very good for 100. They are awesome. They will destroy any system in comparison. 2 to 300, okay, you are pushing it like, okay kind of territory. 5 to 600, yeah, it's just a psychological thing. We want to buy it, but like it's actually bad for you. Like again, still because petrol is so expensive, it still makes sense to buy electric, but that's the only reason why people are doing that at that kind of ranges. So that is a very big issue with electric trucks. So for that sort of system and system which has a very high uptime with the vehicle fleet, for example, many trucks will have, like, let's say they will travel from point A to point B, and in point B they will change the driver, and then that fresh driver will drive the system. So you can literally have a truck that literally does not stop for days. Now, of course, for refueling and all that jazz, but it does not stop. Now electric system, even with DC fast charging, when you're talking about like charging 200 or 300 kilowatt hour of capacity, you need megawatt hour kind of energy densities. That's like that level of supercharger will take huge amount of energy. So fundamentally speaking, for those sort of system, that long charging time is not acceptable. For most things are. For civilian use, is more than enough, because every Tom Dick is like, I'm gonna buy a car, I'm gonna go on road trip. Nobody does that. And people who can afford generally multiple cars, generally right now they are like, hey, let's buy one city car and then one once in a while where we travel for long distance car. It makes more sense. So in those sort of scenario where you have very high uptime or requires huge pulling load, in those sort of scenario, hydrogen does make sense. And it also helps basically electric aircraft. Electric aircraft are taking off like crazy, simply because as a trainer aircraft, they are amazing. Simply because training aircraft does require fuel. Fuels are expensive and they are also noisy. Now these things are generally placed in remote location where everybody's face, and if you're going on top of their roof, people don't like that. But this puppy are far quieter, so that you can have much more classes, training much more pilots without irritating the whole town. So people like that. Like, this is flying off the shelves, so to say. But if this can be upgraded with hydrogen system, you can literally use this as a transport system, because for example, India has many large international airports, few like which are huge, as in like connected from New York to Hong Kong to whatever have you. But there are many small airports that are regionally connected, as in like from state, major state to minor states, and then you have multiple district systems. Now minor airport to district airport is so close that it does not make sense to fly utilizing any jet system. It generally use on propeller system. But if you are using propeller, how about using electric system? Can it be done? Right now, no. Battery does not allow to scale up to that scale where you can even carry, like, let's say 15-16 passenger. You need at least 25 passenger carrying capacity to be reliable, as in like profitable, so to say. So at this point in time, you cannot do that. But hydrogen should in principle allow you to do that. And it does have, in principle, in terms of physics, it does have long-term energy storage potential, meaning you can literally have a scenario where, like in summer, because you have so much thermal energy poured into the atmosphere, your solar farm is going GG in the output, your wind farms are going ultra GG in the outputs, and you will have a scenario where you saturate the grid, like grid cannot absorb anymore. So you can literally convert that energy, electrical energy, into hydrogen and store it for winter months. That can be done. That's how long term it can be stored. You can inherently have, like, giant farms basically that are just storing hydrogen. Basically, like literally, you have a system that is connected with railway networks, and you're just storing hydrogen, and any state that needs it, you just pack the hydrogen and send it there, if the grid is not that capable of, like, dumping gigawatts of energy. So that's possible. You can store energy from like summer for winter, or vice versa, because let's say your solar cells are most efficient when it's cool and very bright. So that could happen in winter. So you'll be like, hey dude, in winter we are overproducing, store that energy for summer. So that's why people are looking into this. Now let's come to real, down to earth. Now, why it's like every Tom, Dick and Harry thinks about it. It's like first thing I get on my comments is like, what if we have excess wind energy, we make solar, hydrogen out of it. Every Tom, Dick, every school children thinks of, because this is something that we do in school. But that's the reality of it. People don't think about that. You need clean water for this, meaning there should not be anything other than water when you're trying to react to it, other than a catalyst or some salts. Now there's the issue. You need clean water, meaning even plants that are utilizing seawater, they have a reverse osmosis plant to filter the water. Only then they send the pure reverse osmosis water to the electrolyzer cell units, and then they have to have salt control, meaning if you have unwanted salts, you will have very high corrosion, and in some cases toxic emissions, which includes chlorine gas. So not only your output will be contaminated, you will be creating something that will not only destroy metals, it will, if it leaks out in the atmosphere, it will be very hazardous in terms of health. So it is something that you have to control. You have to use clean water, and the moment I say clean water, the amount of available places goes down. Then you have to understand salt control is also very critical, because you have to select the salt. If you directly try to electrolyze water, it will work, it will just take far more energy, so efficiency will go down. But if you add too much salt, while your electrical efficiency will go, but you will end up corroding your anodes and cathodes. So there is a balancing act. It's like you cannot just have like tada, whatever have you floats your boat. You have to be mindful with this. And then there are two ways of doing this. One, you have a PEM, proton exchange membrane system, electrolysis system. They are very expensive, because proton exchange membrane could use something as platinum, or like it uses platinum group metals, so they are very expensive. People are working very hard to make it cheap, so they only uses gold. Yes, platinum versus gold is cheap in that regard, but you can understand why everybody builds it, simply because proton exchange membranes are very expensive. But they do have the benefit that they are very efficient. They can go as high as 75 plus percentage efficient, and they give very high purity. I will explain why purity is such a high important concept in this. But that's one thing. You want hydrogen to only have hydrogen. You do not want to have it for other salts to contaminate it. You do not want oxygen to contaminate it. You want just your clean hydrogen. So that would be desirable. And if your electricity is expensive, the high efficiency may justify the cost. Now this is permeable electron membrane, I forgot the name. Basically, this puppy is very expensive. However, most of the time when you Google something, or like you watch a YouTube video, you are looking at what I call alkaline electrolyzer systems. Now they do work. They are awesome. They are something that every Tom, Dick and Harry builds in a school, but they are very inefficient, meaning you would be very lucky if you got even 70% of energy efficiency. Now be mindful, this is not total system efficiency. What you are talking about when you are talking about electrolysis efficiency simply means I put 1 gigawatt of energy, how much theoretical energy is there in the hydrogen. Like given on the mass, you will know the basically how much joules 1 kilogram of hydrogen is, how much you got, you will calculate based on it. It's a mathematical value. So even if somebody opens their mouth and say that we have 100% hydrogen efficiency, does not mean you're gonna get like your whole system efficiency is 100. And so this 70% may not sound that bad, because this is almost as good as pumped hydro, inefficient pumped hydro, or like most thermal system, it is better. But here's this is one step. Thermal, like full cycle, could reach this kind of efficiency. When you're talking about full cycle efficiency, meaning converting that hydrogen into useful work, then the efficiency goes down. So that's the whole thing. The production step, like this is the biggest system I found, where you have like giant container ships with giant electrolyzer cells, and even it's not huge, meaning you cannot just ask any Tom, Dick and Harry. It's like any company like Siemens, ABB or whatever have you. It's like, hey, can you give me 50 megawatt system or 100 megawatt? Or think of it this way, like how big of a solar farm you can order nowadays. India has solar farms that are like 2.5 gigawatt size. Try to buy a phone up a company that can sell you electrolyzer that can absorb that kind of electrical outputs. It can't. Simply, there is no company that sells that kind of huge loads. That's why, because most people are unaware of the fact that hydrogen that are used in industrial processes and like consumed by the humanity is generally made from methane by steam reforming, meaning it's just a filtered version of natural gas. So that's why nobody starts after this. This is the point where hydrogen ends. The moment you start to actually look into electrolyzer, you're like, the best case scenario is that you're gonna get 70% efficient, and the reality is even that is very hard to achieve. When you compare everything, like it's expensive, it requires a lot of electrical energy, it requires very complex machining, it may require materials that are expensive like platinum and things of that nature, and if you use cheap materials, it will not last. Even if you use something like graphite, which is corrosively very stable, it does have some other issues. So there is always issues that you have to deal with, and salt corrosions are something that you cannot avoid, because otherwise you lose your electrical efficiency, but your anodes and cathode will last longer. So if you are using nickel, people may want to do that. So there's a whole lot of issue just in producing electricity, producing hydrogen. That's why not every Tom, Dick and Harry pours into this. It's like that's why I liked cryogenic air energy storage, because there are companies that you can order, hey, can you give me 50 megawatt air handling unit? They're like, got you. 50 megawatt energy distiller, got it. Atmospheric distiller, you got it. So that's why that's a very real thing. Like at the production stage, when you are talking about like large scale, this simply does not work. Then we come to storage aspect, and you have to understand, that's why I specified the purity of the cell is very critical, because you need 97% purity. If you have anything lower than that, it's no longer safe to compress it and put it in a tank, because it's almost a stoichiometric ratio, meaning it can go boom. It will not burn, it will go boom, meaning it will not go, it will go. So that is a very critical aspect. So it is something that you have to understand. In the fuel cell design, people put a lot of effort into it. Like if the hydrogen is supposed to be stored for later use, they will work really hard to make sure the fuel cell is not contaminating hydrogen with oxygen or generally some other gases also, which is coming as a byproduct of the salts that you have added. So that is one very critical aspect, and it takes a lot of energy to compress it. Now some people are working on fuel cells that directly compresses the gas, meaning that it's creating a gas in compressed form. It does work, but the compression is not very high. Now again, it's better than atmospheric system, one bar pressure. People are working on system that can create 3 bars or 5 bars or sometimes even higher than that directly out of the cell. That's awesome. Even though the cell efficiency would be lower, but because you are saving one whole step of compressing the gas, it's really wise to do so. So that takes a lot of energy to compress the gas. Then you may, if you are really thinking about long-term storage, compressed gas will simply leak out. If you want to store it for long-term, meaning days, months or a year, you have to liquefy it. Now thankfully liquefying does shrink the volume to such a degree where it's manageable, meaning the tank still would be huge, but it is something that you can look at. It will take a lot of energy, not only to compress it, to liquefy also. It will take a lot of energy. You lost a lot of energy just doing this. Now your total system efficiency has gone down even more, because you lost 30% directly at the fuel cell. This will burn up at least 10% of your energy trying to compress it or liquefy it, at least that much. And the metals that has to be used has to be special, because hydrogen has an ability to just go through metals. So you cannot just use a thin wall. Like if you look at basically how thin wall SpaceX is using to contain liquid nitrogen, that's super easy. Now if you put a liquid hydrogen there, again it will still be there, but it's like will have the ability to directly tunnel through it. And it will also cause what we call hydrogen basically embrittlement. Basically the metal will become very brittle, so it has to be selected very carefully which metal is utilized. And if you look at the car tanks or truck tanks, they have a metal line, basically metal tank, which is the main hydrogen carrier. It's just, its sole job is there to make sure hydrogen does not leak, and then they wrap it around with basically carbon fiber to give it the strength so it can handle very high pressures. Now these are expensive, these are even more expensive. Now these are comparatively cheaper per liter wise. Like if you look at how many liters of hydrogen is storing in terms of liquid form, this far more efficient. Compressed system, liter wise they are very inefficient, but it's something that you can afford, as in like if you can afford BMWs and all that jazz. So storage is another issue. Then we come to that, okay, you somehow figured out how to make a system that is absorbing gigawatts of power, somehow had a system that can store gigawatts of hydrogen gas. Then you come to the use part. Now use part, the best use is wise use, meaning do not just use it because you have it. Use it in a way where you cannot replace it with something else. For example, heavy electric vehicles, for example trains, or basically trucks, they will utilize it the best, because you cannot replace that system with basically what we call electric vehicles, simply because people forget that people have built what we call bridges, meaning your truck has a maximum carrying capacity, and that maximum capacity generally is far higher than what bridges allow. Not all bridges, many bridges have like solidly built with a proper model, many are not, so you have to be mindful of that. And if your basically truck has a default weight which is like 20-30% higher, or even like twice or thrice as higher than any other system, your payload capacity will go down, otherwise you will damage bridges. So there is a fundamental limit of using electric vehicles. In that sort of places, you utilizing hydrogen system, awesome. So utilizing hydrogen vehicle in those sorts of context helps you the most. And then if you have a lot of surplus production, meaning you're going YOLO on it, you're producing hydrogen like there is no tomorrow, and you're storing enough that you can, like, fire a space shuttle, then you can directly send it to gas turbine. Meaning we have recently started to build a lot of power plants that are utilizing natural gas, as in terms of per kilowatt hour it has the least amount of carbon footprint. Now in those sort of system, you can directly switch it to hydrogen. Of course your flow rate has to be fine-tuned, a bit of engineering has to be done, so jet engine burns it efficiently, but you can buy system that will allow you to utilize gigawatts of power system, meaning there are turbines that are 500 megawatt. 500 megawatts generally is the upper limit, not because you can't build it bigger, it's like no point. It's much better to have two 500 megawatt unit, so in case of one goes down for maintenance, you can still use the other system. So gas turbine can utilize that. That's another, but it does require GG amount of flows, GG amount of storage. Then you may be like, okay, well, why not just use the fuel cell that will be utilized for trucks and all that, because every Tom, Dick and Harry is working on it, be it Toyota, be it Honda, be it basically Mercedes. All those companies are working on it, and their expectation is they should be able to bring it to market by end of 2022 or 2023. And trucks that they are targeting on, they are targeting on fleet, they are not targeting on just trucks, they're talking about this fleet exactly here. The reason for that is they know where to put hydrogen refueling stations. If they know like this, because many trucks have like fixed route, like point A to B to C. If they know this, they will put the hydrogen refueling station exactly on that path, and every fleet operator will have good experience. If the fleet operator has good experience, then from that profit they can start to populate more plants. So generally that's why they are going for truck with hydrogen systems, because the route is kind of known. It's not hydrogen system is not going to be expected to be placed everywhere. Then fuel cell, when you're talking about energy storage in terms of megawatts or gigawatt, you cannot just go to any company like BMW or Mercedes or whatever and, hey, can you give me 500 megawatt system or even 50 megawatt system? They are very rare few companies that can even attempt to build something like it, because this also has what we call proton exchange membrane, and they require iridium, platinum, things that have ludicrously high price tags. So that's a serious issue. So right now there are people working their ass off to make cheap fuel cells. Now if you do not have cheap fuel cell and you need huge amount of power, the best is using gas turbine. For electric vehicles, problems have been solved because the power is kind of limited. You are only going to use like at maximum 1 megawatt of energy, but when you're talking grid scale energy system, it's like we start at like few megawatt hour. So that's the inherent limitation factor. That's why no Tom, Dick and Harry just like building 100 gigawatts of factory that can handle hydrogen. Now so far I have been very down with hydrogen, because that's the reality of it. That's why like we had the technology from 2009, but we are not utilizing. However, there's an alternative to this. Well, instead of using water, you can utilize urea, meaning H2N and H2 weakly bonded with oxygen. Now benefit of this puppy is almost energy positive, meaning when you break hydrogen and oxygen, you're talking about almost it's an energy carrier. You're basically charging it by creating a low high energy state. Then it will combine, give off the energy, done. However, when you're talking about urea is still has energy left. Basically it's almost like petrol. Now like, where the heck energy in this chemical bond came? Solar energy created through photosynthesis. We consumed energy from photosynthesis, we consumed it, and our body created this byproduct. It still has energy. It's almost like how human poop still has energy into it. You can still biodigest it, create methane out of it. Where that energy came from? That energy came from solar. It was just wasted from our point of view. Same for our body. Urea is created as a byproduct of urine. So there's a lot of areas, for example, fish farms, basically milk farms, things of that nature. They produce urea like there is no tomorrow. And urea, like I'm talking about theoretical best case scenario, it can electrolyze at low voltage of 0.37 volts compared to lowest voltage achievable on water, theoretical 1.2 volt. Generally I've never seen anybody drop as below as like 1.4 volts when you are electrolyzing water. Now if you are confused by that low voltage, be mindful whenever you see YouTube viewers and they are working on it and they're like 12 volts, 24 volts, generally their electrodes are far apart. The closer you put the electrode, the less voltage you need. For this sort of, you need micron kind of, like almost touching it. So generally do expect 2 volts if you are actually building it yourself, and it's like stacked very close to each other, but the further the distance, the higher the voltage would be. So in case of urea, you can drop it very low. Benefit of that, it will work almost as energy positive, meaning if you put 1 gigawatt of energy into urine, you will get more than 1 gigawatt of energy output in terms of hydrogen, meaning if you can convert that hydrogen into useful work and with good enough efficiency, it's almost 100% efficient. So human urine has that source, so we do not have to worry like, hey, can we mass produce? Yeah, you can do that. We do that for basically fertilizer industry, but we don't need to. We have urine, like it's a system that municipalities have to deal with. Then why don't make energy from that garbage? So sewage treatment plant can produce H2 and can be net positive. That is very critical aspect, meaning they will consume energy when grid is in surplus mode, and not only they will break down basically pollutant for biopollutant. That's awesome. They are also producing hydrogen, which can be used for later use, and it also produces nitrogen, which can be if you can bottle it up nicely, it has more than enough uses. There is like that's also a profitable system. So you can do that. And what can you do with that hydrogen? Ideally, the most wise use of that is transport industry. It's unwise to try to utilize hydrogen for like grid scale system. Can it be done? Yeah, physics is not stopping you, but you really need to be huge in order to run a gas turbine and then have the spinning mass benefit and have megawatts of energy capacity. So fundamentally speaking, if you have recently, like not recently, like few years ago, people are talking about like urine to a generator. That's what they were doing. Urine has urea. Urea can be broken down in net positive way into hydrogen, and that hydrogen can be used into internal combustion engine. That's what they are doing. However, do not try to run modern engines on hydrogen, simply because yes, they will work, they will self-destruct because their lubrication system is not designed to handle hydrogen. Even the basic engine that you see, even the basic generator, backup generator, they have 100 years of engineering put into it. Do not change its fuel. So we can utilize hydrogen effectively. So this is the best case scenario I found about hydrogen. We have an issue, how the heck you handle human urine, how the heck you handle like cow urine that has been produced in gigaliters in milk farms. Use it to use itself. It is like a partial fuel. Use it properly, and it's like ta-da, now you have hydrogen easily produced. And that low voltage means low corrosion. Like same cell that you are using for basically water can be used for urine decomposition, as in like breaking it down, and it will last much longer. Because of that low potential, it will last much longer. So fundamentally, that's the most potential thing I can see about, like, because we human produce urine. If we gonna produce urine, there is no bypass to that, so why not use that? So that's the best case scenario I can see that, and it does have enough potential that whole of our heavy industry can be running on our urine. So that's why I'm far more excited about this sort of system rather than like having water to electrolysis. Everything other than that still would be there, but this is the best alternative I found so far that actually makes hydrogen useful. So this was my presentation on basically hydrogen energy storage system. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.